Welcome to the Learn Chemistry with Banke channel. Today we'll be talking about bases. Do you know that you use bases every day and that you can test for bases without using litmus paper? If you watch this video to the end, you will find out exactly how to do this, as well as learn the physical and chemical properties of bases and the daily and industrial uses of bases. So can you tell me what is common to the pictures below? The toothpaste, the hair relaxer, and the hand washing liquid soap that you use all contain bases. That's what's common to all these pictures that you're seeing right before you. Did you get that correctly? Oh yes, let's move on. So what are bases? A base is a substance that reacts with acid to yield salt and water only. It is either an oxide or a hydroxide of a metal, for example, sodium oxide, magnesium hydroxide, etc. What are alkalis? An alkali is a basic hydroxide which is soluble in water. Bases that are soluble in water are referred to as alkalis. For example, sodium hydroxide, potassium hydroxide, calcium hydroxide. Alkalis may be strong or weak. Strong alkalis completely ionize in water. For example, sodium hydroxide, potassium hydroxide, they are used in your dental formulations, in shaving creams, and in liquid soaps. These are substances that we use every day. Weak alkali, on the other hand, partially ionize in water. You can find them in use for cleaning drains, bathtubs, and your mirrors. Right. Now, what is a concentrated base? These are bases that contains a high concentration of base in the solution. On the other hand, dilute base contains lower concentration of the base in the aqueous solution. For example, dilute sodium hydroxide, dilute potassium hydroxide. A strong base dissociates completely in water. For example, sodium hydroxide and potassium hydroxide, whereas a weak base does not completely dissociate in solution. For example, ammonium hydroxide. Physical properties of bases are: they are soapy to touch, they have bitter taste, they can turn red litmus paper blue, and concentrated forms of bases and alkalis are corrosive. Now, let's talk about the chemical properties of bases. First of all, bases react with metals like zinc, aluminium to liberate hydrogen gas. They also react with acids to form salt and water only. Industrial uses of bases: they are used in the manufacturing of toothpaste, in manufacturing of soap, and in the baking industry for baking cakes and all. And now let's talk about how to test for bases. So we know that drain cleaners contain bases, right? The pH of drain cleaner is 13, which tells us that it is highly alkaline from using the pH tester. What happens if we add water to the drain cleaner solution? Equal volumes of water. I'm wondering, what do you think would happen? Will the alkalinity increase or decrease? What do you predict will happen? Let's test it. Okay, so we can see that the alkalinity reduces, because initially it was 13, right? Now we have 12.69. So I'm just going to take it back to water. We're going to change the solution to water. Of course, we know that water's pH is 7.0, meaning that it is neutral. Let's test another substance which contains a base. Let's test this hand soap. Hand soap has a pH of 10.0. What happens when we add water to the solution? Will the alkalinity increase or decrease? Let's find out using the PhET simulation just on the screen. Interesting. So we see that the alkalinity reduces when water was added to the solution. Again, look at it. It was 10.0. The closer it is to 14, the more alkaline the solution is. So at 14, the substance is highly alkaline. Right. Thank you for watching. Don't forget to like, subscribe, and share. My name is Banke. We will see you in the next video. Bye.